Hello, everyone. Thanks really for coming here today. My name is Dr. Evelyne Masri. I'm an IC project leader at TWI, Cambridge, UK. An IC, it's an acronym for Non-Metallic Innovation Center in Cambridge. It's a joint venture between TWI, Aramco Tech, and ADNOC. We're trying to expand the operation window for the non-metallic composite pipes in oil and gas. But basically, my presentation today, it won't be about oil and gas as Dr. Amr has done before. It's going to be how to use AI in order to empower construction into high-rise building. A little bit about myself. Basically, I have a bachelor and MSc in civil and structural engineering. I've worked for about 3 years into high-rise building with the ACC and Betabat back in Lebanon. And then I moved to the UK in order to do my PhD into NDT, into reinforced concrete. Then I started working into TWI in Cambridge for the NIC. So basically, have any one of you has been working into Lego when you were kids? We all work together, yeah? Everyone? Okay. So basically what I've done, what I will do today, we'll do a Lego house. We're gonna deconstruct it together, defragment it, look into the supply chain, and then build it up together using AI. Sounds good. So before everything will start, we're just gonna do a pastel analysis in order to highlight the challenges or the gaps into the construction industry. If any one of you is not aware of the pastel analysis, it's basically an acronym that highlights these columns in there, which is political, economical, social, technological, environmental, and legal. So let's start together one by one. So basically for the challenges or the gaps that will face us into developing the AI or a really effective solution into the construction industry is first, basically we're really struggling into a very poor economic situation that no one can basically afford to buy a house. Either like you get a loan from the bank or a support from your family. And that includes the high council taxes. The second one is basically the economical challenge, which is, again, it's a shortage of affordable housing. And the overseas buyer keep it really high because you just need to make a profit out of it. Then the one which is really a high value in there is very competitive market because everyone needs to gain the bid and to construct high-rise building in order to make a profit and win the project. The social, again, is the pressure into the first buyers, especially the young people, because again, you cannot afford it by yourself. And the council itself, it pushes for better social sustainability and regulation. What I mean by social sustainability into any construction site now, the councils, they're pushing into less noise and less pollution around the construction site. The next one is technological. From my point of view, I guess that's the main problem or gap in there, is the older school or the traditional way into doing construction. We just get a contractor, they use like the traditional way, they build loss of error and less quality. And basically that leads us into difficulty into accepting new technological trends and definitely the AI into construction. And the third-party engineering, which they will come to assure a good quality, they push really for this to happen, which is contradicts with the first point, which is using the older school trends. The second one is environmental. Worldwide now, environmental parties and regulation, they really push for green housing or green construction, and as well to reduce the air and noise pollution into construction. And the last one is illegal. So basically, this leads us into more restriction into environmental regulations, and as well into lack of effective schemes for the first buyers as well. So basically, after we highlighted all the challenges in here, that lead us to, we need a really disruptive, effective, and as well applicable solutions or technological solution in order to tackle all the challenges before. Because our aim is first to decrease the cost in order to have a cheaper construction, and as well eventually for the first buyer to afford the housing. The second one is for better construction planning and management, because that will lead us into better quality and better deliverables at the end. The third one is going to be effective materials and waste management, because if you plan well or into your procurement phase into how much material you're gonna purchase. This will lead us into less waste and eventually for effective material usage. The fourth one is smart logistics, but this one I'll cover it more into my slides. And the last one is enhance the quality assurance, quality control, and safety. Okay, so basically, the solution I'm offering today is an automated AI platform, which is, it helps all these construction supply chain into feed in automatically for better optimization, control, and quality. So basically, I will defragment now the Lego house, basically. We're gonna look at each one of those and start to build it up all again using AI and see what's the effect of each one of these columns or stakeholders. So I will start first by the construction materials optimization and smart procurement. Okay, so basically, in every construction site, first you have a consultancy company or a design company. You get from there the design drawing, the geometry, or the BIM model. What we're trying to look into the three main construction materials or phases. First, you have the steel reinforcement, the concrete, and the formwork. If you don't come from construction background, the formwork is basically the molds where you put the concrete in. So these are the plywood sheets with the support, and you pour the concrete inside. So what we're trying as an output into this AI platform, if you put in your design or your geometry or the BIM model, eventually at the end, you will have a clear bar bending schedule for the steel. That means it will give you all the shapes, optimized shapes for all the steel reinforcement. It will give you as well what's the rebar cutting configuration, because into the construction site you have the steel reinforcement comes into standard length. So this algorithm will get you into optimized solution how to cut each rebar for the least waste. And as well, because it's optimized solution, you will get at the end a predictive waste quantities, which is, it's really optimized and minimum. The second one is concrete, because that's the main construction material. We're trying to have as well for the AI platform to tell us what are the optimized concrete volume based into the construction joints. So basically into high-rise building, you cannot pour the concrete randomly. You need to have construction joint, especially if for large floor areas. So for example, the room that we are in today, they didn't pour the whole concrete into one set. They cannot do that because concrete shrinks and they need to control that because you will have lots of micro cracks. So basically, you need to make sure that you have a construction joint where you stop pouring the concrete and maybe the second phase you pour the second one. This model, it will help you to optimize these joints. That means when you order the concrete quantities, they are correct, actual, and they're really tending to have a minimum waste in there. Again, a predictive waste quantities. The third one is the formwork. The good thing about high-rise building is that the verticals, which are columns, walls, and shear walls, they're kind of repetitive. So for example, if I'm into floor one, let's look into this room. Let's say we have this wall. If you look, if it was a high-rise building, it's gonna be repetitive throughout the building, but its thickness will be minimum. But still, this will afford me to, for this platform to tell me, for example, the formwork that you're gonna build for floor one, you can use it again onto floor 3, 5, and so on. So this will help me to optimize the plywood, which is the wood, how to cut it into really configure, into a really smart configuration and installation, and to tell me the formwork reuse schedule, like into each floor. This will lead me into less waste as well into the plywood and the formwork reuse. So we covered so far only material optimization and procurement, how much I'm gonna order as quantities. So what's the business case or the sustainability impact into this idea? First, we're gonna have less material waste because we optimize the concrete, steel, and formwork quantities. The second one, I will have a predictive recycling schedule. That means I have roughly what are the volumes or the weight, and a smart procurement system. This will lead into less carbon footprint and eventually for less cost and faster construction. The second one, so we finalized the material phase. Now we're gonna move into smart planning and scheduling. We know, like project manager into construction site, they love to have control all over all the phases of the construction. They hate us as site engineers to come and bring up really fancy solutions. So this platform, it will help all the site engineers, the foreman, and even the project manager and construction manager into having an automated, updated Gantt chart and a planning system into this platform. So again, let's look into input and output. So basically, we're gonna take from the material, the output of the material phase that I've already covered, the procurement schedule, that means what are the quantities that I'm gonna order, the volume and the weight, and the work productivity rate. What I mean by work productivity rate, each group of workers into the site, for example, the steel fixers, they will have a productivity rate, like how much kilogram of steel they can fix per hour. As well, the carpenter, how much like surface area of formwork they can put together. As well, for the concrete, how much they can basically pour concrete per volume per hour. So I put the quantities of construction material, the productivity rate. So what I will look into? I will look into, the platform will look into all these phases. First, it will give us a signal into the safety people to prepare the zone of the construction that I'm gonna intend to construct. The second one is gonna book for me the equipment. For example, the vibrator for the concrete, the saws, and everything. The third one is gonna give a notification for steel fixers to come fix the steel, and then for the consultant to come and inspect, to give me like, yes, okay, sign off, you can now put the formwork before you pour the concrete. Then it will sign off the formwork installation, then mechanical and electrical team if they want to install any mechanical shafts or any electrical boxes. Then again, to have the consultant to come and check the formwork, sign it off. Then it will get into a decision into the concrete pouring team to come, pour the concrete. Then the concrete has been solidified, to remove it, and at the end to have concrete curing. So all these steps from safety into removing the formwork and concrete is all been digitized. So the output is gonna be a really detailed Gantt chart, an actual Gantt chart that it can be updated automatically into what's happening into the site, but I will cover how the procedure will be later on. And it's associated with each work breakdown structure as WBS and associated cost with it. And the most important, I will have a dependencies mapping. This will mean, for example, these all are interconnected together. So for example, if for any, meaning when I want to pour the concrete batch were delayed. What are the consequences? Because I have a clear dependencies of all these, it can directly update into the Gantt chart what this delay has caused or what are the impacts of these delays. And then update automatically and shift everything. And basically that will give me an actual costing, including all the delays, or even if there are any delays, and as well associated with each work breakdown structures. So far we covered material quantities that help us into better planning and scheduling. Now we'll move into logistics and geospace control via GIS. So I'm working closely with a UK company called Carto Group, which are really smart logistic company, which include the GIS system that using the GPS capabilities into how to control the site. Okay, so basically, if you're not aware of the GIS system, it's like a layer based of all the landscape layers. So for example, you can go from the land cover to structure, to boundaries, to transportation, and you can at each time turn on and turn off any of these layers. What does this mean? This means, like basically, if I build up, for example, around my site of construction and track down the supply routes, the supplier of the material construction, for example, the steel supplier, the concrete suppliers, if I can track down their routes and optimize basically their routes and the time of arrivals, when they need to park, where to have least traffic, basically. So that will give me into effective planning and better control over my site as into surface. Again, it will help me as well to have a logistic tool in and around the construction site. Inside, for example, I can build up some logistic sensors around the site to notify the builders where are the areas that it needs safety notification. For example, you're near a mechanical shaft, be aware. You're near like any heavy equipment, be aware. So this will lead into a better safety into the construction site. As well, around the construction, I can set multiple sensors in order to track for me the air quality, the noise impact as well, in order to reduce it, and the traffic control as well. So this will give me a full control over what's happening into a construction site as just surface or areas. Sorry. Okay. So far we covered materials, planning and scheduling, and GIS system for better control over the site. The second one is structural monitoring and quality control. Okay. So it's very simple. The smart way is to do some embedded sensors throughout the construction that you can use it post-construction, that means after the construction phase. For example, I can embed, has any one of you is aware of how the concrete material works? Anyone? Okay. So the concrete material, how it works, you pour it as a liquid and then it solidifies. Once it solidifies, throughout like the solidification, it needs to exhibit temperature. The problem is that the more the temperature it exhibits, the more you have micro cracks in there, which is in the future, it can lead into a major cracks into the construction. So the aim here is to control that temperature that it can be exhibits from the concrete. So what we do, we embedded into the steel reinforcement some thermal sensors. When we pour the concrete, we can track down the development of these temperature in order to control a better quality of the structure later on. We have vibration sensors in order to, again, as I said before, in order to maintain better social sustainability. That means less noise around the construction site. Air and noise quality, because our aim is to have better alignment with the environmental and social sustainability regulations. For post-construction, we usually put into acoustic emission sensor, which is for monitoring the structure. It just, when you have a crack that it penetrates, it basically initiates some small signals. These signals can be detected by the acoustic emission sensor and sent via Wi-Fi into the third-party engineer just to alert them there is a crack into penetration. The new technologies that we're trying to cover here is the virtual and augmented reality. Yes, we're doing fancy stuff. So basically, we're doing 360 cameras, virtual reality, augmented, and mixed reality. I'm not covered in detail just to give you like what are the differences into these. The 360 camera, just you sitting as a site engineer into your office, you can have these cameras just to cover up the area of interest, like the one into the construction phase, because sometimes some of the construction or areas, it's not accessible by human beings. So you can use these kind of cameras. The second one is to virtual reality, like you can just have a VR into your office again, and to point out into some meetings this kind of structure or element structure like beam or column of interest, rather than all the team going into the site. The third one is augmented reality. It's really nice because you can overlay different structural objects on top of each other, like for example the concrete, then the finishing, mechanical and electrical equipment. So you can basically over-predict how the structure is gonna look like. The third one is a mixed reality, where it basically merge all of these for better planning and visualization. So basically, we covered materials optimization, planning and scheduling, structural monitoring, better quality control, a GIS system, and blah, 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 and blah, blah, blah. There's a really nice quote by Leonardo da Vinci, I don't know if you can see, but it said, learn how to see, realize that everything connects to everything else. So into any construction site, there are lots of stakeholders in there that are trying to implement the work. In real life now, no one talks to each other in an effective way. And everything into the construction site, they are connected to everything else. So for example, if I have a rainy day, I cannot construct because the water content that is raining, it's gonna implement into really deficiency into the concrete because it changes for me the water to cement ratio. I will stop the construction, that will cause delay. I'll postpone some activities. So everything is connected to everything else. So this will lead us into really effective, a complete AI platform, which is smart decision-making tool. So what we're proposing in TWI is basically all these stakeholders that I've talked about is to put them into one AI that feeds in automatically. So let's start. So first we talked about optimization of construction materials. We put it in there. That will lead us into smart procurement, a better waste management, and as well recycling schedule. So basically, we created a VR tool. So for example, if you have a pile of plywood as waste, you can just put the VR, just walk around it into 360. It can predict for you the volume of this waste. Why we need these kind of things? Because you need to plan ahead where to basically post these wastage and into which company or which main field. The second one is like optimize the planning and scheduling. And as well, we talked about the smart logistics into how to use the GIS system for better supplier route and control of traffic. And for safety control, to notify the builders that please be aware of this safety and healthy issues. And to have a better life cycle and structural monitoring. And that will lead us, basically, into an effective full dependency mapping. So basically, if I implement all of these into one platform, I can really generate, using machine learning, how they are connected together into one platform. And this eventually will lead us into smart decision-making tool. What I mean by that is that this AI, eventually, if there is a misinterruption to the construction, it will automatically update, and it will give you a certain set of decisions that you can select with a clear mind of what are the impacts. So for example, if the consultant comes to the site and he needs to inspect the steel before you put the formwork and you pour the concrete, one of the rebars, they're not correct into the sizing. He will be, no, you need to stop and you need to basically replace the steel rebar. So you stop yourself, you call the steel fixer and so on, but these are all manuals. This automated system, it will notify the steel fixers, there is an error there, come and fix it. It will delay the formwork people to come and put the formwork and eventually the concrete and so on and so on and so on. So basically, I'm a huge fan of Professor Alan Turing, which is the father of AI. I don't know if you're aware of him. He's the one who basically decrypted the Enigma code back in World War II. He's a fellow of the University of Cambridge. He said, we can only see a short distance ahead, but we can see plenty there that needs to be done. And this is really actually the case. We're all here enthusiastic about the AI, what it's capable of, but the more we learn, the more we figure out there is lots to do. Thank you. Any questions?
Thank you, Dr. Evelyne. I come from the construction industry. We're architects. And thank you very much. This is very interesting. But one of the challenges that we face, and this is when we speak of AI, only as good as the data you put into it. And I believe one of the main challenges in the construction industry is actually collecting accurate data. Because like you said, many of the processes that we use in construction are quite primitive and quite manual, and there's a lot of human error in them. So what, in TWI or in your personal experience, what can we do about data collection in the construction industry? Thank you.
Thank you for your question. So basically, some of the things you can connect it via sensors, if it's like temperature and so on and so on. But some of the things that are like decision related. So what we cover like nowadays, I know like still into the Arab region is really limited. But like in the UK, everyone into the construction site, like the main group managers or like the group leaders, which is basically one person per each 5 workers, they do have a tablet. And they do have access to this AI platform, and they do have this basically scattered decision. For example, if I have, as I said before into my example, if I have like one steel rebar which is really, so they can basically just open the iPad, just select what's the problem. Is it like material or into any category, selected. They can directly, this platform, it's a plugin into the BIM model. They can go directly into which beam, which column, which shear wall, select it and select even the rebar. It's into that precise. And we're now into the demonstration phase. We already secured an Innovate UK funding with Skanska, which is a Swedish construction company. And we're now into basically the demonstration phase of this AI platform. So basically, as a question, if you have the correct tool there, with the correct resources, you can implement it. It's not that hard. But again, into the Arab region, I don't know if they do have funding to have these basically iPad and so on, because the plugin is already developed. You just need to put it into the BIM, implement the design and the BIM model, and then everything is automated. Yeah. Okay. Any other question?
Thank you for the presentation. So, well, you mentioned about using thermal sensors within concrete or the acoustic sensors. So you probably over time you can even build predictive models that try to actually see ahead of time if there are any issues. But the question would be, if you notice after you pour the concrete and in the solidification process, if you notice that there's an unusual heat flow or from the acoustic sensor, if you can start detecting that there are some cracks that are happening already, are there preventative measures that you can do about it within that kind of phase, or what is the treatment process in this phase?
Aman? So basically, yeah, this is old school, I'm just using it. So basically, when it comes to the thermal, let's just differentiate between like cracks that cannot develop into when I'm pouring the concrete. It starts after it solidifies and shrinks. But for the thermal, there are lots of actions you can take in order to delay this temperature exhibition. You can either like put a retarding material in there as a superplasticizer. So it's a fluid that you put inside the concrete batch that it will delay the solidification of the concrete. This means to delay the temperature rises. So for example, into one of the high-rise building in Lebanon, which is Sama Beirut, when we were like exhibiting the foundation, we cannot pour the concrete into like one batch into the foundation because it's huge. What we did, we put these thermal sensors into the foundation, and we realized, and we only pour it during the night just to have like least control over the temperature. And we realized at some point there's a huge problem because the temperature, it was huge. We started inside the batch plant into ordering some retarders for the concrete to solidify, just to have much more control over the temperature. Yeah, hopefully I answered your question. Any other question? Okay, thanks a lot.